Hello, my name is Jared Fortney. This video is an instructional video for group networks. Today we're going to discuss we're going to have a brief discussion about project management concepts. Three major areas that we'll cover are the fundamentals of scheduling. We're going to discuss some terminology including critical path, float, lag, relationship types, and some other associated terminologies. And we're also going to discuss the critical path method and discuss a general understanding of how it works and how one would utilize it in scheduling and planning. So we'll begin with the scheduling fundamentals. Now, a schedule's primary purpose is to manage the amount of time that it takes to complete a project's scope of work. So, as you can understand, there's a number of things that you have to do that you've probably identified in your project. That would basically entail everything that you need to do from start to finish. All of those activities put together would be your project scope. A project schedule generally it consists of a list of critical activities. They all would have estimated durations, and they generally would be linked logically together in order to forecast the total project duration. So once you identify all of the activities that are within your scope, basically the things that you have to finish or complete to finish your project, you would go down the list of those items, and you may get with your estimating department. You may look on, use some references online or in some project management books to determine what an average duration for this specific activity is. You can ask people with knowledge in that industry or of those activities from their personal opinion. How long do you think that this activity should take or would take or generally does take to complete? Once you've assigned all of those durations to the activities that you've identified, what you're going to do is take all of those activities and you're going to link them logically with relationships, also called activity ties, or there's precedents and predecessors and successors that you would tie together. And once you've linked all these activities together, essentially what you do is, depending on the software that you're using, you would run the schedule, and the CPM algorithm would determine the start and finish dates of all those activities based on the relationship types and their durations, and it would show you when the project finish would be. So, like I just said, the critical path is a mathematical algorithm, and it uses your activities and durations and the the applied logic to calculate all of the activity starts and finishes, and essentially gives you a finish date on your project. Now, from my own personal experience, something I'd like to discuss is from a general standpoint, when you're approaching your project, you're approaching your schedule, something that you want to avoid is is telling your schedule when you think that things should actually start or finish. I've seen some people on a WBS, which we'll talk about later. It's a work breakdown structure. They'll create a WBS that's by month or by year, or even on the activities that they create, they'll say, we'll say a potential activity would be complete January's work. And from a scheduling standpoint, this is a fundamental error because you can't tell your schedule when you're going to do things. The key here is to make sure that the durations and the relationships between your activities are correct and are actually reflecting the reality of your project. And that will tell you, that will allow the software to tell you when these activities will actually occur. It's just a generally a fundamental error to try and label things as this month or this year or this day, because it's counterintuitive to the way that the software and that the CPM, the critical path method, kind of works. Okay, the next activity area that we're going to discuss is scheduling terminology. We've already talked a lot about the critical path. The critical path is generally the longest and also the shortest possible path through your network of activities. So it's every activity in your schedule network that has an effect on your project finish. So any delay, meaning if you have an activity that's on the critical path and you do it 2 days later than you had anticipated, it will affect the finish date by 2 days. And in the contrary, if you were to finish that activity earlier, it could potentially come off of the critical path, or and join a different fragment within the schedule. The next terminology that we're going to discuss is, next term is total float. Now, total float, when you see it in scheduling software, you'll see the TF field, total float, and what it's telling you is that it's the amount of time that activity can be delayed before it affects the project finish date. So what it's essentially saying is, if you have 4 days of total float, that means that you can delay that activity for 4 days before it joins the critical path and essentially affects your total project finish date. There's another type of float, it's called free float, which is often can be confused with it. But free float is the amount of time you can delay a project before it affects its downstream or successor activity. You don't want to confuse these two, because free float is generally associated with an activity that's not on the critical path. Because every critical path activity affects its downstream successor activity, whereas this is just a float that is truly specific to that activity and not specific to the critical path or the path through the scheduling network that will affect the finish date. The next activity, the next term, the scheduling term that we're going to discuss is lag. Now, lag is a way to delay or accelerate an activity's start or finish date in order to create concurrency with its predecessor or successor. So generally, what we're discussing here is, if you want an activity to, let's say, for example, you want an activity to have a finish to start relationship with another activity, but you know that it's actually going to occur 2 days. It's going to finish 2 days after that activity starts. So it's not a true finish to start. I mean, literally a finish to start is the second one activity finishes, the next one can start. So with lag, what you're able to do is, if you were to put 2 days of negative lag, the successor activity would be able to start 2 days before the predecessor activity finishes. So what you're able to do with lag is create concurrency, where two activities can maintain a finish to start or a start to finish relationship but they're actually able to overlap each other and go on at the same time. And that's what I mean when I say concurrency, is that the activities will actually have some overlap and will be able, they'll be able to go on at the same time. Now, we've talked a lot about relationship types, and so we'll do a quick overview of those. I've already mentioned the finish to start. Finish to start activity is the most popular activity, is one that almost all scheduling softwares, that activity will be the default activity relationship type. So when you just apply a relationship, it generally will be a finish to start activity. And what that means is that a finish to start activity that is drawn between two activities, it will say that if the predecessor or the first activity, it will finish, then releasing the start of its successor activity. And there's a lot of ways to say this, but generally in scheduling speak, they would say that the successor activity has dependence upon its predecessor. So the activity that is waiting to start or has dependence on the predecessor is the successor activity, the second activity generally. So, for example, we have to get into the car before we can go to the store. So you must finish getting into the car before you can start going to the store. That would be a finish to start example. The next type is a finish to finish. And generally a finish to finish activity is when you're saying that two things must end, their finish date for these activities must be the same. So we want two things to finish at the exact same time. You would draw a finish to finish activity relationship between these two activities. An example of this would be when you're cooking dinner. You would draw a finish to finish relationship between the cook the mashed potatoes activity with the cook the turkey activity. You wouldn't want to cook the mashed potatoes and have them finish 2 hours before the turkey is finished cooking, because you don't want the mashed potatoes to get cold. So you want these two activities to finish at the same time. These activities, and this finish to finish, and the next one I'm going to discuss is start to start. The start to start activity is very similar, but the two of them are the ones that you wouldn't need to utilize lag on, because it's another way of creating concurrency between two activities. You're basically saying that these activities can go on at the same time, but they have to finish or start at the same time. Now the start to start is just like the finish to finish. You basically are saying that these two activities must start at the same time. So when you draw a relationship, a start to start relationship between one activity and the other, you're basically saying that that the successor activity cannot start until its predecessor activity starts. Essentially saying that they must start at the same time. But based on dependency, it's also saying that you must back to the cooking thing, you must start making the broth for the turkey at the exact same time that you start cooking it, because you'll want to be able to use the broth to pour on the turkey while you're cooking it. And there's probably a better example for that, and there's many out there, but we're just kind of doing an overview here. And the fourth relationship type, which is probably the least likely, is a start to finish. And you won't use this very often, but it does have its place. It's something that you would need to know how to utilize. But a start to finish basically means that the successor activity cannot finish until another or its predecessor activity starts. And I won't go into the examples. You can look them up on the internet, but there are some, there are a few examples of when this is applicable, when it's actually a good usage for a start to finish relationship, and they are out there, but they're few and far between. We've discussed predecessor and successor, and it's basically a nomenclature used to describe an activity's order in a sequence. So sequence is a key word here. When you tie when you tie activities together via their relationships, you are creating a sequence via precedence, and that's just one activity coming before the other. So, and this predecessor successor relationship is applied via the relationship types that we just discussed. Alright, now the third area that we're going to discuss about general scheduling and scheduling fundamentals is understanding the CPM, which is a critical path method of scheduling. Now, the critical path is the essential technique for using CPM. The essential technique for using CPM is to construct a model of the project that includes the following. And I touched on this briefly in the first area, but you're going to create a list of activities required to complete your project. You're going to assign duration to each of those activities, or the amount of time that it takes for you to complete each of the activities in your schedule. And then you're going to draw dependencies between these activities. So that's basically what we discussed a little bit earlier. You're going to break down your project into bite-sized chunks, little activities, all the things you need to complete. Then secondarily, you're going to apply a duration to each of those activities, which is the amount of time that it will take to complete the activity. And then you're going to tie them then together via the four relationship types that we just discussed. Now, using these three inputs, the activities, the durations, and their relationships, the critical path method is going to utilize an algorithm, and it's going to calculate the longest path through your schedule. So you can see the definition here. Using these values, CPM calculates the longest path of planned activities to the end of the project, and the earliest and latest that each activity can start and finish without making the project longer. So an important part there is it's saying it's the longest path of the planned activities through your project. But another way to look at this is it's the shortest or fastest way that you could possibly finish the project as well, which is, a little it sounds like it contradicts itself, but it doesn't. For you to find the longest path, the longest amount of time is the shortest time that you can finish it in. So essentially, when the algorithm goes through, it's looking at it and going, what are the longest periods of, what is the longest path through my schedule, and essentially also isolating the shortest amount of time that you could actually complete it in, based on the relationships applied and based on the durations that are applied to each activity. So this process determines which activities are critical, which is the longest path, and also calculates the total float, or the amount of time that each activity can be delayed before it extends your total project duration, also, which essentially means you're extending the project finish. So in project management, a critical path is a sequence of project network activities which add up to the longest overall duration, and this determines the shortest time possible to complete the project. And that's what we just discussed. So, in summary, the scheduling fundamentals revolve around breaking down your project into digestible sized activities at whatever level of granularity that you see fit, taking those activities and estimating their duration based on your own personal knowledge, based on maybe some group that estimates these kinds of activities. I've worked in many industries, and the Mechanical Contractors Association of America has a website you can log on, and you'll look at installing a pipe of a certain size, a certain material type, and a certain length, and it will tell you exactly how much time it should take to install that pipe. So you're going to estimate the durations of all your activities based on hierarchical knowledge, or the knowledge, your personal knowledge, or knowledge of experts. And thirdly, you're going to tie these relationships or these activities together via the 4 relationship types, and then CPM will run it through its algorithm, and it will basically tell you when your project should be finished. Okay, once again, my name is Jared Fortney. This has been a Group Network tutorial on scheduling fundamentals, and we'll see you later. Thank you.